everybody, how are we doing? So good to see you. I had the video off. Oh my gosh. Hey, Jackson, Cassandra, Jessica, great to see you here. If you have questions in the chat, drop them in the chat. I love seeing some first, second, third right there. But if you have questions, let us know. We did a little chapter 5 today. So one of the big chapters, we could do some 320. Hey, Kayla, great to see you here. What are you wondering about? We got some 320 big stuff coming up right here. So whatever you're wondering about, let us know. Could you show us how to copy a chart from the homework and put it into Jump? Sure. Which problem are you wondering about, Brent? Mention the problem. Let me get my Pearson pulled up right now and say, Brian, can you have us work this one? Is it one of those OGIV charts? Those are interesting. Those are fun graphics to look at. Which problem do you want us to look at, Brent? Your call. You get to pick. We'll look at that problem. We'll solve it right here. If you mentioned the start of the problem, the chapter, Alex, great to see you here. Let's throw out some Mubot points. Mubot, you awake? So Jackson, Canvas content, contingency tables for chapter 3. You bet. We'll do some contingency tables for chapter 3. Let's take a look at those. So we got that next. Let me write these down. Brent has a copy the chart question. So copy chart from my Pearson. And then Canvas content contingency tables. Okay. You know the right. Oh no, Jake. Jake, send me a message. It does show the right answer when you look back on it. So send me a message. So can you mention a particular one? Because which chapter? Or are you talking about just the data? Like if you say like a certain one, like chapter 3, chapter 4, whatever chapter you're working on. And if you have a specific problem, because then I can look at like a specific, are you just talking about bringing data over to Jump? Like, let me know a specific one. Here, we'll do some Canvas content, and then we do it next right here. What does wrong sign in by argument mean? I'm using the equal sign. Can you send me your code, Kayla, in Discord? Message me your code in Discord, and I'll take a look, and then we can do that. Chapter 4 is connecting today. We might hit a lag bump, but the lag bump should go away. I don't know why we had a few of those. We had 2 of those during class. YouTube does not like us today. I don't know why. And so charts can't be copied to Jump, but this could be. Let's go look at a tough question right here on chapter 4. Yes, data. Cool. Okay, let's go look at some chapter 4 data. Jake, yeah, message me on Discord if it's something specific. Definitely. And then say like, hey, Brian, I got your Discord message going on. Okay, let's put a note right here. We have, this question should be copying data over to Jump. So this is Stat 201, Chapter 4 quiz. And this is back-to-back stem and leaf. So let's go check out the back-to-back stem and leaf. Here we go. Okay, timestamp at 4:10 in office hours. Let's do this. So with this right here, back-to-back stem and leaves are displays of quantitative categorical data. We have here 2 regions, region 1 and region 2, which is categories, region 1, region 2. And then we have here quantitative data on some sort of measure for them. What are they measuring? They're measuring something about them, a quantitative metric. So a population growth rates, fun times, and very interesting data. Sarcasm. And then we have here box plots. So stem and leaves are back-to-back stem and leaves, and side-by-side box plots are displays of bivariate data where we have a quantitative variable of interest and a categorical variable. Categorical splitting it up into the 2 regions here. So if you bring this into Jump, you can actually solve it pretty quickly. So let's talk about how to bring data into Jump right here. To bring data into Jump, first, I'm going to open up Jump here on my computer. 2 seconds. Things are a little laggy. I don't know why we got lag on this computer. I need to buy a new computer. Don't need to buy a new computer yet. So here we go. We got Jump open. So have Jump open on your computer just with this. Don't click inside the data sheet if you have it. Just have it open. Now we're going to go over here to the box and go to copy to clipboard. So this is how to bring data into Jump whenever you have data. Copy to clipboard here. Now you want to notice something. Notice if it has column names or it does not have column names. Yes or no, does this have column names? Yes or no, does that have a column name? These are columns. And does this have column names? Yes or no? What's up, Troy? Good to see you here. 50 points, Troy, showing up. Does that have column names right there? Are there names to those columns? Yes or no in the chat? Are there names to those columns? This is very important when copying data into Jump. Are there names to those columns? Like when you look at the top of the column, is there a name at the top, like a title to it? Are there column names? Very important question. We have to know this when we're copying data. Are there column names? I'll see what chat says. What does chat say? Are there column names? Yes, Brent right there for some points. Brent, you are right. Kayla and Jessica, you are right. There are column names. So that means when I copy with Control-C or Command-C, when I go back to Jump, I need to go to Edit, Paste with column names. Make sure when you paste, you either paste or paste with column names. When you paste with column names, you'll notice that it's blue. This is the right way to paste. This is the wrong way. If you make an error, do not try to restart it and repaste. It often doesn't fix it. Will it fix it? Oh, it did fix it. Well, just try to restart, do a new data sheet and repaste. Make sure to paste with column names if column names exist. Make sure to not paste with column names if column names don't exist. So this one's a little bit tougher to make a graphic of. This one right here, we actually need to do, you know what you could do? You don't have to make the side by side if you don't want. Might be able to go to graph builder. We could just drag right here and do this. Let's go here, do that. Did I do region? I did region 1. Oh my gosh. What are you doing, Jump? Stop telling me things. I don't think I can start over. I could do one box plot here. You know what you could do? Watch this. Analyze. I'll do it the right way here in a moment. Distribution. Select both of them. So I'm just selecting both, putting them both here in this window. Boop. And now I go to OK, and we see box plots. I'm going to go to the top right arrow and go to stack. These are stacked histograms or stacked box plots. And we notice right here that region 1 has no outliers and region 2 does have an outlier. So region 1 has no outliers and region 2 does have an outlier. We have now narrowed it down to graphic choices what or what. With my graphic and Jump right here, I have narrowed the choices down to what. Region 2 does have an outlier. So I've narrowed it down to graphic choices what and what. So I've narrowed it down to which two of the graphic choices now by knowing region 2 does have an outlier. That point up there is an outlier. So now I have narrowed this down to region choices what or what. B or C. And actually, I can kind of tell which one it is just by looking at this. Notice the whisker right here and the length of the whisker. So the length of the whisker tells us it's actually which choice. You can tell pretty quickly by looking at the length of the whisker. Also, the median is not symmetric around the quartiles. So what answer? Yes, you can. Great job right there, Troy. You can so Troy's actually fixing it. So great job, Troy. There is a way to fix it. I often try to not have people fix it. Like to do it right. And so the answer is it is B, because if you look at the median is a little bit lower in the box. It's down here. It's not towards the middle. This one has the median towards the middle. You can also tell if you check out data points like where the values are at, but just understanding like how to look at this and be like, there's the median, it's lower, it's towards the lower end of the box. If you were to turn this upright like this, it would be there. So that is the box right there. We should know some values when we look at this, that is the max. Make sure to not forget about the range of this. Can anyone estimate the range of region 2? Very simple question that people sometimes get wrong. The range of region 2 is what? What is the range? You can actually see it if you look over to the right. To be a little more specific, we do 2 questions where one is Marvel's Heroes and Fighting Students Born. Yeah. We'll talk about stuff like that in the Canvas content. You got it. I'll make a question like that. So Jackson, we'll do that here next. You got it. And we got time for more questions. We only have one question after this, so drop those questions if you got them. And be like, hey, we can talk about that. Jackson, you're next on the Canvas content. What is the range of region 2? Estimate it by looking at this or find me the exact range. Great job, Kayla. Let me put yours. So we have Kayla's question next. Discord question, Kayla. I got that next, Kayla, right there after Jackson's. So what is the range of this data? What is the range of region 2? What is the range of region 2? Now you can find the exact answer, about 60-ish. I'll take about 60. Do you know the exact range? The exact range could be calculated over here. So Brent, great answer right there. Brent, some points. Good guess, Kayla. 63 is a good guess. The exact range is what? So the exact range is what? Who knows the exact range? So try using the stem and leaf to calculate the exact range of it. Like down to the, not decimal, but down to the digit. What is the exact range of it? So use the stem and leaf to calculate the exact range. 61, Kayla, great review knowledge right there. And Brent, great review knowledge. 61 because 62 is the maximum, and there are 2 observations at 1. That's what the 1, 1 represents. So we're just practicing our knowledge right here. And you see your guesses were pretty good. 60, 63. I actually was guessing like 65. I was looking at it too quickly. So I was like, oh, it's lower 60s. So we can look at the stem and leaf to get the exact number. This one down here on the bottom describe the shape of the 2 regions. Region 1 is definitely more tightly clustered, super evident. Region 1 is unimodal, one mode, unimodal, modal area. Region 2 is bimodal. You see modal peak. Think of it as 2 mountain ranges. Around all modes, the distributions are... this one I always worry about. Fairly symmetric. If you get that one wrong, email me and I'll fix it. This one I'm worried about. And there is an outlier in region 2. It's either going to be right skew or fairly symmetric. I don't know. The fairly symmetric is a good way to... It's decently symmetric. Like, this is symmetric around that mode. This is symmetric around this mode. Fairly symmetric. Does it like it? It does. If you put slightly right skew, I will give you points for that. There's maybe a little bit of right skew, or it's fairly symmetric. Like, fairly symmetric, a little bit of right skew for this distribution. That one's definitely symmetric, definitely unimodal. This one's fairly symmetric. Fairly symmetric is a good qualifier word, so that's why I chose it. If it said a little bit right skewed, then I'd be confused. Like, is that a little bit right skewed or fairly symmetric? That's how we describe it. So great work on this. That's how we get data into JUMP and kind of practice our describing of data. Let's head back. Okay, so we're going to do some Canvas content. We're going to make up our own versions of these Canvas contents. So let's write our own questions. The number one way to answer Canvas content questions, the number one way to practice them, is to be able to write your own questions and answer your own questions. So watch this. Are you ready? About a question number 4, Brent. Let me do that. Brent says, Discord message. I got you on the list from Brent. Thank you so much, Brent. Great way to do that right there. I might have to answer on Discord, or I might try to answer here. Let's find out. So we're going to do this. We're going to make up our own questions. Let's go do this. Here we go. Okay. So we're making up our own questions for Canvas content. Let's go here to Marvel versus DC. So let's say publisher. And we got here Marvel and DC. Now, you might think I'm crazy, but I'm going to copy these a few times. There we go. And the reason I'm doing this is I'm going to look at certain superpowers like flight. Let's say heat vision. Oh, no, I want to go flight again. What am I doing? Flight, heat vision. Let's say super speed. What's another cool superpower? I need another cool superpower. What is another cool superpower? Flight, heat vision, super speed. We got speed right there. And superpower. And what is another cool superpower? Stretch. Gotta get that stretchy power. Stretch power right here. Invisibility. Oh, that's cool. Miss Marvel. And does Miss Marvel have that? Stretch power. We're thinking of Fantastic Four right here. Stretch. And we have here invincibility. Oh, no, invisibility. Invisibility. Read minds. So Kaya right there. Awesome stuff right there. Let's add that. Invisibility. I'm going to take away some heat vision. I'm going to go with mind reading. No, that's what happens when you get off by one letter when you're typing something. Okay, there we go right there. And we got the count of individuals that meet these groups. So we're looking at in the history of all these publishers. So in the history of all of these publishers, you know, mind reading for Marvel would be like Dr. Xavier, Super Speed Marvel. Who got Super Speed Marvel? Oh man, I should know this. Flash is DC, Super Speed. Quicksilver. Quicksilver is Super Speed Marvel. Can I name someone who meets each of these categories? So let's go right here and take a look at this. It's probably actually more like this. I'm gonna do that. And so stretchy power got, what's his name? Elastic Man or Plastic Man, all different people. And invisibility, Miss Marvel, and things like that. Okay. So let's take a look at this. What do we get when we visualize two categorical variables? What graphic do we get when we visualize two categorical variables? What graphic do we get when we visualize two categorical variables? When we visualize two categorical variables, what graphic do we get? What graphic do we get when we visualize two categorical variables? Two categorical variables will get us a what graphic? Two categorical variables will get us a what graphic? So what graphic do we get when we visualize two? Contingency table or mosaic plot, right? It's down here in the bottom corner where I'm hovering over that, so I can't appear on the screen as I do this. Contingency table or mosaic plot. So we don't usually do the others, but contingency table or mosaic plot. So we're actually going to put our two categorical variables right here. Does a publisher explain why someone has a certain superpower? And then the count goes right here for the observations. And here we are. What do you notice about... Oh, I didn't know. Whoa, that's interesting. I didn't even realize I was doing that. That's cool. What do you notice about the DC superheroes immediately? What just jumps out to you immediately about the DC superheroes? Like, I did not even realize I was doing this. What just jumps out to you immediately? And that's a great way to display it. What just jumps out to you immediately about those DC superheroes? Just immediate jumping out. A lot more of them fly. So watch Invincible. Invincible's such a good... Oh, it's an adult show. But Invincible's a good show on Netflix. I can't wait for season 2 Invincible, which is not DC, I don't think. A lot more of them fly. When you look at Marvel... A lot more Marvel really has the leading way on what? And you can see it right here. Marvel really is leading the way on what superpowers. So a lot more DCs fly. And Marvel really is leading the way on what superpowers? Mind reading and let me make this. Oh, I got to recopy it then. Marvel's really leading the way on mind reading and all that good stuff. Let me make the contingency table, but make it how you can see it. Marvel's got a lot of mind reading, a lot of invisibility, and that's why we make contingency tables, because contingency tables kind of make it easier to read, or excuse me, the mosaic plot really makes it easier to read what's going on in the contingency table. So here's the questions. Are you ready? Let's put a question over here. We'll get a new Word document and write ourselves a question. Okay. So we'll take this data and see if you can solve these questions. So we'll make it nice and big right here. There we go. Oh, font. Here we go. Plus. What percent of Marvel heroes can fly? Oh, we don't fly. Yeah, we do fly. What percent of Marvel heroes can fly? Solve this question right here. This is the way to practice it. Like, all these questions are just like this. This is a conditional display. What percent of Marvel heroes can fly? What percent of Marvel heroes can fly? So now you're doing conditional. Like, is that if it asks of the dark chocolate, it's asking of dark chocolate. Only those. Think, what are we asking right here? If it says like what percent of dark chocolate, that's going to be a conditional display, hints for your Canvas content. So what percent of Marvel heroes can fly? So you're talking about how many heroes right now? What percent of Marvel heroes can fly? Try to solve this. What percent of Marvel heroes can fly? So how would you solve this? Just you have to practice, do as many examples as you can to be like, that is a conditional display. We're looking at only Marvel heroes. So what percent of Marvel heroes can fly? This is conditional display. What kind of display? We'll always ask this. And then what's the answer? So it might be 47.7. So the answer for what percent of Marvel heroes can fly, well, we can actually cheat and find the answer. But I'll show you how to cheat in a second if you have the graphic. So it would be of all the Marvel heroes, what percent of them flying? So 115 out of the 241. Great job, Jessica, right there. And great job, Troy, also. That is the percent of Marvel heroes that can fly. Great job. And we can go here and actually hover over it, and it'll show us the answer when we hover over it. Really? Was it going to be tiny? What's going on? Now let me click on it. Well, that's weird. Okay. Can't click on it today. Click and drag the pin zoom. Usually, I can click on it, but not today. Well, that's the way it goes. No idea what's going on with that. So with this, we have the percent of Marvel heroes that can fly. How about this? What percent of heroes are from Marvel? What kind of display is this? So this is a what display to say what percent of heroes are from Marvel. This is, does that just, it does. What percent of heroes are from Marvel? What percent of heroes are from Marvel? There we go. What percent of heroes are from Marvel? So what percent of heroes, now it's fixed. It's some weird thing with jump right there. What percent of heroes are from Marvel? What percent of heroes are from Marvel? And you can actually kind of see the answer a little bit. It's hard to see, but you can tell more are from Marvel than DC. But what percent of heroes are from Marvel? This is called a what display? If people might answer the question, because then what's the answer? So you have to know where to look. Is it conditional or marginal? So what percent of heroes are from Marvel? That's a what display, and then what would be the answer? Because that's going to help you figure out, like, oh, that's a blank display. Because when we're talking about all heroes, what percent of heroes? It sounds about that much. So it's a marginal display, which is over here. You can tell it's more than 50% by looking at the mosaic plot. And so it should be mathematically, the percent of heroes from Marvel are the 241 out of the 414. And great job, Kayla, right there. Exactly. And great job, Troy. That's the percent of heroes from Marvel. So when you think about the questions you're getting, even if I go over and do a mimic of another question, if you have Born in TN, this is in, and if you have honors program, it's just changing what we have right here and changing the names of the variables. I don't know how this is going to turn out. Let's go account right here. So we have to know what it's showing us. Sure. Let's take a look at another version of this question. Does someone being born in TN explain if they're in the honors program? And here we go with another type of the question. Oh, that's some big differences. So let's see this. Here's another virtually identical question. And let's do the following question, which is just like your Canvas content. So now the question asks, what percent of students are born in TN? Just took time to read the instructions carefully, guys. It's not, yeah. Laura, email me if you put percentages or something and it counted you off by putting the answer the wrong way. Laura, email me. I will fix that. Laura, email me. Laura, 100 points. Please email me and remind me to be like, hey, Brian, can you fix this? I don't think the question should be worked that way. I need to probably fix that too. I think that's not fair. So Laura, email me. I will give you those points back. And tell me if there's an issue with like the percentages. I will give those points back. It's very specific about it, but just email me and say, hey, Brian, I put it in as this. Can you give me 1 points back? As long as you did and everything's like that, you get your points back. Laura, thank you, Laura, 50 points. Thank you for being here and saying that. Just be like, hey, Brian, Cassandra too, just email me. I don't care if I have 100 emails to respond to later tonight. I'll fix each of those. I consider that a mistake on our part. I should have fixed it. I didn't. So now I'm going to fix it. So please email me. Please email me. It does say to do it. So technically it is wrong, but I will fix it. So just the thing is asking it. So it's always make sure around. Exactly. It's so specific. It's the way test questions go. Just tell me if you think something's not fair. You always have the right to be like, hey, Brian, I don't think this is fair. I got this right. And I'm like, yeah, let's change it. He's got to ask. So what would this be? What percent of students are born in TN? What's this right here? Take a look at that graphic over there on the side. What percent of students are born in TN? Who knows this? We'll do 2 more questions here on this. Figure out what percent of students are born in TN. Is that what kind of display is that? When it says what percent of students are born in TN, what kind of display is that? A lot of good Canvas content practice right here. Then when you get tested, you're like, that's a what display? The answer is this. Like you want to get into the mode, you look at it and say, oh, I know what kind of display that is. I know what the answer is. I know this. Trying to get people all the practice. As many practices we can do. If you you'll get to test, you'll be like, psh, that's this display. That's a marginal display. Because all students, great job, Kayla, right there. It's a marginal display, and this applies to 320. Covering it this week in 320. One of the great things is a lot of our classes converge. So what percent of students born in TN? There's the answer right there because it's out of all the students. So what if we ask, what is the probability of a TN student born in TN, of a born in TN student being an honors student? There's the honors community Discord starting up. Shout outs to them. What's the probability of a student? Gotta be careful the way you say it. What's the probability of a student born in Tennessee being an honors student? How did I do the numbers on this? Oh, that's interesting. Apparently it's very high. You can kind of see the answer over here. Wow. Owen Wilson, your thoughts?
Wow.
That's what he thinks of that. Apparently. I was not born in TN. I was not born in Tennessee. According to this graphic, what's the probability? It's pretty impressive. Pretty, wow. So this is a conditional display because we're talking about within one variable. You have to look within. Great job, Jessica, there on the answers too. And then we're going to jump over to, I think, Kayla's the next question. We have time for more questions, so drop them in the chat. 71.4, that sounds accurate. So out of all the born in TN students, there's 240. So 200 out of the 240. Oh, don't worry, Jessica, 100 points. Laura, that is the right answer. And we can double check our work by hovering over, and it shows us the answer. There's the answer right there. So that is the answer for this group. Don't worry if you got it wrong. I'm throwing out another 100 points. We get them wrong here just to get them right on the test. That's the practice. So the answer is 200 divided by 240 because we want to look at all students born in Tennessee and then the ones that are in the honors program. So 200 out of the 240. Does that make sense? Jessica, do you have any questions on this? Thank you, Jessica. Those 200 points go out to you right there. No, that's all right. You went down the wrong because it's yes and yes or yes and no, right? So it's a little bit confusing. The Marvel DC one was a little bit easier to look at because we just had like Flight and Marvel and DC. So the yes and no's kind of make it confusing. I'm not even joking. I think I almost looked at the wrong column too because you could look at this one and do it the wrong way. So a little bit more confusing when you have yes right here and you have yes right here. So that's a little bit tougher way to ask it. Just make sure you use the right column to say only the students born in Tennessee are 240 of them. So Jessica, thank you so much. 100 points right there. More points. We got them wrong here just to practice, and then we can double check. Finally got my Discord account back. Had to delete the account with 14 days. Oh, wow. Jackson, great to have you on the Discord. Yeah, exactly. It can be tricky. You'll see me get stuff wrong. Like, all of a sudden, I'll be like, wait. And I'll be like, oh, no, I looked at it wrong. And that's the great thing about Jump is we can check the answer right here. We can also check these distributions, which these are the whats. What is this telling me right here? Who could communicate to me what that number, what is this telling me right here? So what does 63.64 mean? Last question right here on this. What does 63.64 mean? What does that number mean? Like, tell me the answer to, let's just put a question right here. Like, what is the context of that number? 63.64. What does that number mean? Like, give 63. So it's, well, we can tell what it is. What display did it come from? What variable? And level. Ooh, some terminology from 320, variable and level. So that right there is what? Give that context. Yeah. Troy, great answers right there, Troy. Exactly. That's how many students are or what percent of students are in the honors program. So it's a marginal display because it's in the margins. Remember the margins right here? 63.64. So that's the percent of students in the honors program. That would be 280 out of the 440 because it's the amount of students in the honors program. Let's double check our math. 280 divided by 440. Watch me get it wrong. There it is right there. So it's the percent of students in the honors program, 280 students out of the total 440, because it's the marginal display of whether or not you're in the honors program. So honors program, marginal display. I hate how it reverses it where it's on the bottom, where it's on the side there, but it's the percent of students out of all students who are in the honors program. So this is all students. And then you can also see more students are born in TN, 240 to 200, 200 in this group and 240 in this group. So it shows you the widths of the bars on the bottom. It's a great review right there. Let's go check out Kayla's question. Thank you so much, Kayla. Here we go back to some 320. I'm gone. I'm back. With this, let's go over to the Discord right here. And Kayla's question is, so there's a lot of things that are running apparently for a hold. I haven't gone back and checked it all, but number 12 specifically is confusing me by saying wrong sign in the argument. Kayla, this is the mega practice for activity 2 for loops. Oh, it's the for loop stuff. Okay, cool. Number 12. Kayla, is it all right if I show your code? Type capital YES in the chat as long as it's okay if I show your code. So let me go right here and put a note. Type as long as I think you're okay with it. If I show your code, because this is the activity practice, are you okay with me showing the code? So BAS 320 For loops. Okay, cool. For loops, light question. Okay. Let's go check this out. Awesome, Jessica. Seeing a little bit right here. Great work, great practice. Excellent job. Okay, so what we have right here is we have basically the sequence of oh no, it's fine. You know what you can do? Watch this. If you highlight your code and press Control I, it'll resyntax it. So actually your code looks fine. It's basically what it should look like. On the first line of code right here, you are creating a vector of 500,000 lights turned on. On the next line of code, you are turning off, you don't need comments, but for anyone wondering, turns off light at position 1. So we turned off light at position 1. This is setting I to 2. That's not needed. So interestingly enough, I know what you're maybe thinking is that you're initializing I, but I actually gets initialized by the code right here. You do have to have the lights vector being used, but we're going to remove this because the for loop will do that for us. Watch as I close out my global environment and start with a fresh new global environment, which is the brain of R. And then you can see right here, this runs. Now there might be a problem on the loop. Let's see what it does. Ooh, it's doing something. It's doing something. Okay. That's what you're saying is the problem. You have the... Okay, so you are storing the word off. Wait, it actually worked. Might have worked, Kayla. Okay, I think I know the issue. I think I might see the issue, Kayla. Maybe not. What's the issue? Because I didn't have this, did I? Error in sequence default from by I. Wrong sign in the by. Okay, it's mad about this. Okay, I think I know what the issue is. Okay. What is the last number? No. I know what the issue is, and it worked. It just kind of broke. It's fine. So let me ask you this. A few questions. You ready? Sorry, I need to sleep more. Let me ask you this. What is the last value I becomes when the loop runs the way you've written it? And I'll show you the answer and how this works. What is the way you've written your loop? When it runs, I will become this at the last time the loop runs. If your loop runs, I should become this. So when your loop's running over and over and over and again, you want I to become this the last time it runs. What value should I become the last time it runs? Exactly, Kayla, you're on the right. Exactly. I will go from 2 to 500,000. So the last time the loop runs, I should be 500,000. So here's the issue. The last time the loop runs, it's going to basically be doing this. Does this make sense right here? So the last time the loop runs, and we could turn this into whatever this is going to be 2 times it. So it's going to start at this, and we'll put some commas to make it make more sense. So the last time the loop runs, it's going to solve for this. Now, these commas won't make this run, but don't worry about that. So the loop is going to go from 1,000,000 to 500,000 the last time it runs the way you've written it. So what I'm doing is I'm pretending, so take a look at this scalar right here. I am plugging in the value of I, because the last time the loop runs, I becomes 500,000. Now, this is not the way the loop should be written, but the last time the loop runs, I becomes 500,000. So this is what it would solve to. Does that make sense? Like when the loop plugs in 500,000, the code becomes this. Like that's what it'll become. It's still the skeleton, but if you were to solve with that value of I of 500,000, this is what the code would be running. Does that make sense? Because remember, the last time the loop runs, it is 500,000. So I could make it, let me try writing it this way for you. The last time the loop runs, it's going to run this skeleton, but I is going to be 500,000. And so since I is 500,000 right here, this would become this right here. Like, it's still I, it's still I, it's still I. Like, every time it runs, it's still I. Like, it's still a skeleton. We're just showing what it is. Like, I is this, but it's still just I if you're running it as the skeleton for, like, what we were doing on the assignments. So this mathematically just solves out to this right here, and then you can see what the sequence is. Now, What this is going to do, though, is a problem. We're going from 1 million to 500,000. Would you have to go up or down to get to 500,000 from 1 million? To get to 500,000 from 1 million, would you have to go up or down? So to get to 500,000 from 1 million, so go from 500,000 to 1 million, would you have to go up or down? Would you have to go up or down? And here we'll just look at just this sequence right here. You'd have to go down. So if you try to make a sequence from 1 million to 500,000, you get the following problem. Because you have to go down. So you'd have to go down. Like if you try to do a sequence right here from 8 to 2 by 2, it'll say wrong sign. But if you say -2, it'll go down because that's what you're going down by. Does that make sense? Like the error in saying wrong sign is saying you can't go from this to this by a positive number. You have to go by a negative number. So here's the thing, though. Our loop broke. The code broke because what was the last value that I became? It actually tried it and then it broke on it. It broke right after 250,000. And so double check. I think I must have done this because we don't want to go to 500,000. We only want to go to half of that. So no, it's kind of good that you broke it. The code actually worked and created the vector. So it actually created the vector. The loop just said like, broken, not working. So it tried to do it. It tried 250,001. It tried that and then it broke and it gave you that error message and it stopped. So rather than letting the loop break, this time when I'm running the loop, I'm going to stop it before it gets to that value. And if you look at right here, check this out. Now it's stopped at that value. Does that make sense? Like I'm not letting it get to those values it breaks at because when I do this, when you plug in 250,000, what is 250,000 times 2? So 250,000 times 2 would be a sequence from 500,000 to 500,000 by 500,000. And if you solve this, because right now this is 250,000, all you get in that sequence is 500,000. So this is the last number because then you're just saying turn off light 500,000 if it's not turned off. So you stop it after this point because at this point your from would be bigger than your to. Does that make sense? Like if you go to this, your from becomes bigger than your to and you'd actually have to go negative. So that's where the error occurred. Once again, to see the code right here, the code broke when it got to 500,000. The code broke when it went to 250,001 because it's saying I can't do that. So we're not going to let it get to that number. We're going to say stop at this. And now if we stop at that right there, it's going to stop at it. Oh, I might have made that typo. Did I only do 50,000? I might have only put 50,000. Kayla, 100 points. Like we should look at the video. Maybe sometimes my brain just blanks out and I might have put 50,000 but we should do half of it because then the sequence would end. Really? Oh, I think I made a speed ran it at the end because I was talking about how I did this one on the plane, I remember. But this one's a tough one. I remember when I first did it and being like, holy mackerel, how do we do this? I'm about to go look. Yeah, go check it out. Kayla, thank you so much. And great questions right here. Really good practice. And we'll be doing a new activity tonight. Check out the new activity. Good practice. This is one of the biggest activities. And Kayla, if you conquered this, Kayla, I want to throw you another 100 points because this was easily one of the hardest assignments probably in the whole class. By looking through and practicing this big assignment right here and understanding what you're doing by storing into positions, by making a repeating sequence, this whole assignment right here, which it looks like you did, extra questions on to practice this one right here. Like this is a lot. This is, nice job on the balance right here. This is pretty tough stuff right here. So, yeah, great work. We'll head back to the main screen. I think we got a Discord message from Brent. Let's go check that out. Oh, good. No. Kayla, don't worry. Very easy. Got Brent's message. Okay. Could you please tell me on the quiz? The answer is A. Excuse me, symmetric. They both look symmetric to me, Brent. Basketball teams in League A. Okay, basketball teams in League A. Quiz 4. Let me go to basketball teams in League A. Basketball teams in League A. Let's go check out Quiz 4. Brent's wondering about the basketball leagues in Team A. Let's take a look at this basketball league question. Some basketball leagues. Is it baseball or basketball? Let me go look at that again. Looks like baseball. Okay. I think so. Baseball league scores. Let's go check this out. Baseball league scores. Could you go to the 75th percentile on the Canvas content quiz? Yeah, which one? Is that Canvas content 5, Cassandra? I'll put that on the list next here. So is that quiz 5, 75th percentile or so, something like that? Tell me which one. Stat 201, chapter 4 quiz. Baseball leagues. Okay, let's go check this out. And Cassandra, let me know which one and we'll check it out. So we've got here some baseball leagues and we want to figure out which box plot is associated with it. Now, as always, we need to know that side-by-side box plots are a bivariate display of categorical quantitative data. So quantitative because it's box plots. You can see up there in the top corner, chapter 3-4. You bet. We'll take that here next. And then categorical because it breaks it into groups. So side-by-side box plots right here have a quantitative Y and a categorical X. Make sure to know that. Cassandra, thank you so much. So with this right here, create an appropriate graphical display. Now, if we're looking for the 75th percentile, where is the 75th percentile? This might help answer the question, Cassandra. Where is the 75th percentile on box plots? So in any of these, if we were to look at, if we don't know which one's right yet, but the 75th percentile is always where on a box plot? Is it here? Is it at the top of the whisker? Is it here? Is it the line in the box? The 75th percentile is where? Now, we'll figure this out. We're going to use jump to help find the answer. So let's go here. We're going to copy the data with copy to clipboard right here by clicking the little box. I'll show you again where that's at. So click this little box right here. Click this little box, copy to clipboard, and then hit Control or Command C. There are column names right here. So since we know there's column names, when we go into jump with a file, new data table, file, new data table. Let's go right here and go to edit and then paste with the column names and drop those questions in the chat. We got some more time after this. So now we're pasting the data. Make sure it's blue for quantitative. Then let's go here to analyze and distribution. And with analyze distribution, we're going to double click both of these average games, average runs by games. And now we can look at both leagues right here. So let's click OK. And now we can see once we stack them, here's the big thing. Are there outliers in these box plots? Are there outliers in these box plots? And let's do the following. Let's go to same uniform scale. Are there outliers in these box plots? Yes or no? Are there outliers in these box plots? Yes or no? Are there outliers in these box plots? What do you think? Who thinks, are there outliers in these box plots? Are there outliers? Thoughts on that? Outliers, yes or no? So outliers are things that are far away. Is that an outlier? Is that an outlier down there? Are there outliers in these box plots? What do you think? So if we see an outlier in a box plot, we should see what looks like a what? If we see an outlier in a box plot, it should look like a what? So what would outliers look like? And do we see outliers in these box plots? So every time you see outliers in box plots, which are part of the range, don't forget to conclude them if they do exist. But if we see outliers, they should be a dot. I don't see any dots, so there are no outliers in these box plots. This one does not have any outliers, nor does this one. So we're down to, oh, it's that graphic. Well, there we go. Because that has an outlier, that has an outlier. No. So it has to be the graphic right there. That is the answer. Now, here's the big thing, Cassandra, and this is what we should know. When it comes to the 75th percentile, the 75th percentile in a box plot is where? Let me do the following for you. we should be able to clearly label a box plot with the 5-number summary. So let's take a box plot for region A, drop it in right here and make it a box plot. And let's add in the 5-number summary. So here we go. Let's take a look at this. I'm going to click done, and we've got a box plot, and let's bring this over to Word, and this will kind of answer both the Canvas content and also the question right here. So who knows for 100 points, and let's go over to a page. Who knows for 100 points where the 75th percentile is? So who knows for 100 points? Mubot? He's being weird today. Who knows where the 75th percentile is? So take a moment. Well, we should know another name for it. It's 12. Brent, great job right there. It's 12. Because the 75th percentile, same thing as saying you have 3/4. So that would be Q3, not 2. Q3, which is 75th percentile. And the 75th percentile is always where? It's always at the top of the box. Q1 is at the bottom of the box. Who can find the IQR right here? Who can find the IQR pretty quickly? The IQR is just the difference those things are away, which is actually the same value as something else. So the IQR is what? The median is the middle line in the box plot. The min is the lowest number. And the max is the highest number. Watch out for outliers because sometimes the whiskers are not the min and the max. These are the min and the max respectively. But the IQR is what right here? It's 8. Brent, just awesome work, Brent. More points in the chat. And so that is the IQR right there, which is the distance between 12 and 4. Does that make sense, Cassandra, right there? A little help with the Canvas content to identify where is Q3 or where is the 75th percentile. These words right here are synonymous, Q3 and 75th percentile. So Q3 and 75th percentile are both located right there. Does that make sense? Awesome. Yeah, no, great work. 100 points again. Thank you for asking. A lot of these questions converge on what we're trying to learn and what we're trying to do. If you're looking for the 75th percentile, you're looking for the top of the box plot or just the top of the box plot. So knowing your positions in the box plot and where they're located and knowing terminology like Q3 or 75th percentile, just think of 3/4, like how much is 3/4? 75% of the data, and that's where it's at. So hopefully these graphics right here can help and people can utilize them to answer the questions with what we have going on. So going back to the Canvas, or going back to the question right here, I think this was Brent was asking about the distribution of runs per game is what? It's fairly symmetric, right? I think it's better be. So roughly symmetric in League A, and really, are they going to say it's skewed? I think they're going for a little right skew. This one's symmetric. Hey, Alex, good to see you here. Let me know if you have questions. This one might be a tiny bit right skew because of the pull on the whisker. I think it's ridiculous if it says it's right skew. And League B is definitely roughly symmetric. The typical runs scored in League A so League A is higher than League B, while the variation in League A is, there's more variation in League A. Why is there more variation in League A? Because what? They both have about the same this. But League A has a much larger this, which is a measure of spread in box plots. They both have about the same range, but League A definitely has a larger what, which means more variation. League A and B have about the same range, which is a measure of spread, but League A definitely has a larger this. What do you see right here when you compare them? And I'll make it even more obvious. IQR, Brent, exactly, which is a measure of spread. So Brent, 100 points right there. Here's the IQR here, and here's the IQR here. So definitely larger. And so we'll double check. I think it's going to say it's a little bit right skew. If you're wondering why it's a little bit right skew, remember right to the high, what left to the low, whatever way the tail goes. So this is a little longer here than this, and that might be a little bit pulled to the high side. Little skewed. This one is symmetric around the mean. So that has good symmetry right there, where this one has a little bit more right skew. Maybe maybe, I don't know. We'll find out the hard way. It's iffy. The two teams playing for the World Championship, League A team, League B team, both were at the top of their respective leagues. Did either team score an unusual? No, because there's no outliers. Nothing unusual. Neither team scored an unusual because there's no outliers. It is a tiny bit right skewed. If you did answer that that is symmetric, just let me know. It's roughly symmetric, I'd say. If you put roughly symmetric, you can always ask for your points back. Once again, if you watch these videos right here and you do a little thing that's like, I'm like, it's basically symmetric. Because I'd say roughly symmetric is a good way to describe that. Is it perfectly symmetric? No. Is it roughly symmetric? Sure. Is it a little right skewed? Yes. Is it very right skewed? No. It's in that range of like kind of, this one here we're talking about. This one here is kind of symmetric or a little right skew. In truth, and here's how you could answer it statistically speaking, is you could go right here to the summary statistics and you could actually ask, and it's saying it's a little right skew. Let's find out the real answer. The real answer to the question is going here to skewness and clicking OK, and that is a tiny bit of right skew. If it has positive, it has right skew. That's about as small of right skew as you can get. The skewness of the other one that it says is roughly symmetric. There's skewness. Wow. The one that it says roughly symmetric, you're welcome. Yeah, you generally look at the lines would indicate like the whisker right here being pulled out is what they're indicating the right skew on. So you see this whisker right here, Brent, they're indicating skew right there. Now, a better example of indicating skew from a box plot, a much better example would be something like this data where you can kind of tell by how I'm going to do the data right here. I'm going to make some right skew data. Okay, let's analyze this data right here of age, and let's look at a box plot of it. Actually, you know what? Easier, just look at the following graph builder. You can make box plots horizontally, and here's the box plot, and here's the 5-number summary. So this is a much better example of a right skew box plot, and you can see that there's a pull to the right side, because below the median is what percent of data, Brent? So below the median is what percent of data? I know that sounds like a crazy question, but below the median is what percent of the data? Like, it sounds like an obvious question. Like, it's just like, well, it's the median. So below the median is what percent of the data? So it's kind of, because it's the median. So below the median is what percent of the data? 50%, right? So half of your data is down here. That's the spread of the bottom percentage of your data. Does that make sense? And then another half of your data is up here. And even if you exclude the outlier, it'd be this. Do include outliers and ranges. That's a young person right there, 38. So this is the spread. Like, there's the same amount of data up here as there is down here. Your data is more spread out on the what side of the median. Your data is more spread out on the what side of the median, which this is a clear indication of this right here. Your data is more spread out on the right side of the median because there's 50% on each side. Like, there's the same amount of data, the same amount of observations. There's the same amount of people here as there are here. Which spot has people more spread out? And if you're wondering, just so you can see it, there is more data spread out to the right. Like, this is the same amount of data here as there are points down here. So I think it's right there. It's more spread out on the right, right? Like, if you look at the points, there's the same amount of data down here as there is over here, same amount of points. So this is more right skewed. There's the same amount of observations. I think it's exactly 9, isn't it? Oh yeah, there's 10 points right there. If you can see, it says 10. And if you go right here, there's 9 points. I might be missing a median value. So you have the same amount of data up here as you do down here, but it's more spread out on the right. Yeah, that's exactly what we should be seeing. It's like, okay, that's right skew because the whiskers and the distances apart are kind of equidistant. Like, the 50th to 70th percentile has more of a pull to the right side, where this is more tightly compact. Like, this is more tight, this is more pulled out. So there's more right skew to this distribution. Yeah, and that one right there on that assignment, it's ridiculous. It's funny to me that the bottom distribution actually has more skew to it. It might not look at both of those are roughly symmetric. In truth, the answer should be for the top one, it's roughly symmetric. Like, I mean, if you were to increase this a little bit, it would actually look almost perfectly symmetric due to the box plot. And we know, oh gosh, due to the histogram, my brain turned off right there. Bin widths are going to change the way these looks. It's pretty symmetric. No matter how you look at it, it's pretty symmetric. Not today, my person, not today. I know the answers to the questions. I've done them more than enough to know the tricky, cheating ones. I think we're in open question region. Let me see. Wow, that was a really good review of box plots there. Brent, thank you so much for those questions. What questions do we have? We're in open question time. We're in that time where it's just open questions. Brent, really great review of box plots. That way we know on the test how to read them and how they look, and we understand just the intricacies of them. If you have questions, let me know. Brent just racking up all those points today. I think it's time for a haircut. Try to make my hair a little better. Getting that long hair. Real quick test. Text. Let's see. Oh, can you help with Stat 201, Chapter 3, Question 2? Of course. Of course, of course, of course. Of course. Let's go check this out right here. Let's go check this out. Arden, so good to see you here. Perfect time to ask. Let's go. This is question number 2. The song's even ending right on time. Oh, it's the rain, no rain, the dreaded rain, no rain problem. You bet. One of our favorite questions of all time. The dreaded rain, no rain problem. Let's go here. 5802. Stat 201. Chapter 3. Homework. Rain, no rain. Okay, let's check this out. So this is the dreaded rain, no rain problem. But we have to remember, what does this data mean to us? So if you look at this data right here, when you wake up every day, there's a what for the day's weather? The night before. What is there for each day the night before? Every night before you go to bed, if you do go to bed, there's a what for each day. You would hear the what. You tune into that radio, turn on the radio, and you hear a what for each day. What would you hear? You'd hear the forecast, right? So when you think about this right here, that's one data point you could collect on. What was the forecast for today? So you'd go right here and you'd say, okay, I heard the forecast. And last night, they told me rain. Now, don't go too crazy right here. I just want you to read it this way. Or let's do this one. How many times was no rain forecasted? Now be careful. I'm just trying to draw your attention to just something. Just go that way on it. How many times did you listen to the radio and they said, it's not going to rain tomorrow? So try to answer this. How many times did you listen to the radio and they said, it's not going to rain tomorrow? Turn on the radio and they say, tomorrow it's not. We got to do the voice. Tomorrow it's not going to rain. That's what it sounds like when you listen to radio. How many times did you hear it's not going to rain tomorrow when you turned on? How many times did you hear it's not going to rain? Just going right there on the forecast. How many times did you hear it's not going to rain tomorrow? It's just, this is the way to be like, okay, that's the times I heard it's not going to rain. How many times did you hear it's not going to rain? So the total amount of times the forecast said not going to rain was how many? Who knows that one? And right, if you don't know, just feel free to say, I don't know. That's a great answer too. And then we can explain how to do this. So how many times do we get, it's not going to rain? 274, Laura, excellent work. Jumping in right there for 100 points. Great work, Laura. So we have, it's not going to rain 274 times by adding up these two numbers right here. But think about this also. You have what they tell you is going to happen, and then you have what actually happens. How many times did it actually rain? Now be careful, this is a different answer. How many times did it actually rain? Like, what I mean by actual is you wake up and you look outside and you say it is raining today. So at any point during the day, if it rains, you might say it rained today. Like, did it rain today or not rain today? Well, we're talking about at any point. So today is a no rain day for me. Great job, Arden, right there. Look at perfect answers. Yeah, exactly. So 32. So you notice right here, explain to me when you went to bed last night and then you woke up in the day. Tell me about this day right here. Just tell me about these 26 days. These are 26 different days where you went to bed and you heard what, and then you woke up and what? Just explain to me, like, I went to bed and heard, remember the forecast, and then I woke up and it was doing this at some point during the day. So those 26 days represent what? So those 26 days would represent days where you went to bed and you heard this. Remember, your first variable is what you went to bed and heard. And then your second variable is you wake up and what it's doing at some point during the day. So remember, you've got two variables. They predicted it was going to rain, and it did rain. Exactly, Arden. Perfect answers. Yes. Now think about this. Here's where they predicted it's going to not rain, and it also did not rain. Those are good things. Why do you think I'm shading this in red right here? Tell me about these. Let's go to these 65. Go to these days. These 6 days, you have a big interview. And what does the forecast tell you the night before on these 6 days? Like, we're just talking about a day of the year where you have a big interview. You're like, I have a big interview. Let me look at the forecast. And it says this. You're going to love the weatherman on these days, or weather person. So you look at the forecast and you're like, forecast says this. I'm going to go out, leaving that umbrella at home. Why? Those 6 days right there, forecast said what to you? These are very important 6 days that we don't like these 6 days. These are our bad 6 days. Our 6 days that are like, oh gosh, really? Really? It's one of those days. Forecast said no rain, but it actually rained exactly. So they were wrong. That's why we're coloring these a different color right here. So these were 6 days of the year, of the 365 days in the year, where they said the forecast was wrong because they said it would not rain and it did rain. We do also have where the forecast is wrong, where they said it would rain and it didn't rain. So now we're walking around with an umbrella and it's not raining. We're like, well, not the end of the world. These are really the days we don't like. So when we think about this, we can use this information right here to answer the question we were working on. So we're just going to kind of keep this to the side right here and use it to answer the question. On what percent of days did it actually rain? So we want to know on what percent of days did it actually rain? So we need to know first, how many days did it rain on? So first, we want to know how many days did it rain on? So we could add in the numbers for the conditional, or excuse me, the marginal. Misspoke right there. The marginal numbers would be, great job, 32. Yeah, well, that's the margin right there. There we go. Arden, great work. So, and why is it 365? 365 days in the year. Make sure you do these as a percentage. So that's going to be changed right here to the following number. Arden, thank you so much. Arden, another 100 points. And Zachary, great to see you here. Am I rounding? I am rounding correctly. On what percent of days was rain predicted? So now we need to go back to our graphic. And Arden, first, you can answer the full. On what percent of days was rain predicted? So now you need to go to the forecast for rain. So Szechuan, chapter 5. We'll finish chapter 4 and then we'll do chapter 5. Fun stuff. Chapter 5 is a big one. We'll finish it chapter 5 next class, but today we start it. On what percent of days was rain predicted? So first, how many days did it forecast? What percent of days was rain predicted, forecasted? So predicted means forecasted. So how many days was rain forecasted? This is another marginal display right here because we're talking about for all days. And so what percent of days was rain forecasted? So we have to know how many times was rain forecasted. So I'm adding it up into my head. How many times was rain forecasted? And then what percent is that? Exactly. Laura, great work practicing right here. That's the marginal. And so 91 divided by 365 is the answer. 91 divided by 365 times 100 and 24.9 rounds to. There we go right there. What percent of the time was the forecast correct? What two numbers would I need to add up to find what percent of the time was the forecast correct? To find what percent of the time of the forecast was correct, we need that they predicted rain and it actually did rain, and then they predicted no rain and it actually did not rain. So we need to add both of those numbers. So how can we find out the amount? Like, first off, the amount of time, then we need to turn it a percent by dividing by 365. So how many times was the forecast correct? So we've got it color-coded right here to help out with answering the question. What numbers do we need to add up together to find out when they predicted rain and then it actually did rain? They predicted no rain and it actually did not rain. So we'd add up two numbers on here to get basically the amount of times it was correct, and then we divide by 365 to find out the percent of time it was correct. So what do we have right here? What do we have? Let's see what people think. So we need to add up the times it was correct. I'll start bringing up the calculator. 294, great job right here, because 26 and 268, oh my gosh. 26 and 268 divided by 365 times 100. I sometimes ask these in the chat and I want people to answer just to make sure I do the right work. Like I know the answers, but it's very easy to make a decimal error and like do that right there. Great job, Laura, and everyone. Great work. Now this one's a bit weird. This question sounds a bit weird, but it's asking, given it rained, the forecast was correct. So this is a marginal right here. How many days did it actually rain on? That's my last question. We'll solve this right here. How many days did it actually rain on? So this says, given it rained, the forecast was correct. I know it doesn't say it in full words, but that's what they're trying to show you is, given it rained, the forecast was correct. That's what that says is, given it rained, the forecast was correct. So how many days did it rain on? So we have to think about given it rained. And we're talking about specifically, we are talking about this right here. So how many days did it rain on? So given it rained, the forecast was correct. So given it rained, the forecast was correct. Then we should be able to get that number 81.3%. So given it rained, the forecast was correct. So how many days did it rain on? It rained on how many days? And great work, Laura and Arden. I just want to throw you another 100 points. I appreciate all these answers. Great work. Arden's already solved it. Arden, great job. 26 out of those 32 days, the forecast was correct. And you notice that is 81.3 when rounded. The other numbers will solve out too if we find them. But you'll notice right here that these are very similar. If it rains, the forecast is correct about 81.3% of the time. And if it doesn't rain, the forecast is correct about 80.5% of the time. Is there evidence of an association? No, because these percentages are very similar. Rock knows. It doesn't matter if it rains or does not rain. It's very similar. Like the probabilities of the forecast being correct is virtually identical if it rains or does not rain. So we would not say that it raining gives us a higher probability of the forecast being correct or not correct. Arden, I think you asked about this. Arden, did you just solve that one and ace it? I hope you did. Really good question. Really good practice on knowing conditional and marginal displays. It doesn't call them conditional and marginal for everything, but understanding like, how do I read this table? What does it mean when we ask two categorical variables? And then given it rained, the forecast was correct. Like understanding how to solve this and read this. And great job, Arden. Excellent work on the assignment. It's a tough one. A lot of people get stuck on this one. It's, don't worry, like it's in a good way. Like I know when we get to this question that there's going to be questions on it. So I'm always ready for the rain, no rain question. We got time for more questions. Drop them in the chat. Let's head back. I think we got, when is this assignment due? Let me look at the assignment manager. We've had some questions today. What we got due? The 14th. Oh my gosh, it's due tonight. We could do another one. Is there any more chapter 3 questions? Good chapter 3 question. So we've had a little chapter 3 work. It's due tonight. So any other chapter 3 questions? Really good stuff on chapter 3. Due tonight. Due tonight. Yep. A lot of due dates. I'm always afraid to say when something, I was like, I think that's coming up. And then we have stuff due on Thursday or Wednesday. A lot of assignments coming up. Chapter 4 coming up. So this is where it gets scary. Let's see how things are doing. This is, I say scary because we're basically starting an engine and then we're trying to get the car running. And so, yeah, we got about 2/3 have done the homework. About half have done the quiz. So definitely starting now is great. If you have another question, let me know. I might choose one myself, but which one are you working on now, Arden? If you just want to work through it together, this is your opportunity to say, hey, can you do this question? This one right here, the placebo one, or any other question you're wondering about. If you just want to hear a solve of it and talk through the concepts, just Laura, Arden, anyone, Zach, just put that question in the chat and we can work through it, have a video walkthrough of it, and I'm sure somebody will be like, yes, Yes, that's how I work that problem. That's the answer. Like, not just the answer, but the knowledge. That's the knowledge of it. So we'll see. If we don't have a question by the end of the song, I will pick a question. Let's see. How's Discord doing? Oh. Great answer. I'm going to spawn with them. You too. Okay. Let's take a look. I'll come up with a... Oh, we're talking about some MMOs in the gaming chat. Question 4 on Chapter 3 homework. Arden, of course. Let's go check out question 4 on Chapter 3 homework. Question number 4. Cool. This one's actually harder on the homework. So let's go check out question number 4 on the... I think it's the acceptance rates. So... Stat 201, Chapter 3 homework, acceptance rates. Let's go check it out. Here we go. Okay. So with this question, the reason this is easier on the quiz is it actually gives the answers at the end. It's a weird question in that way, that it gives the answers when you finish it. But a lot of these right here are based on univariate data because we're just analyzing whether or not people get accepted. So we're doing a frequency distribution of people being accepted, and we need to figure out the accepted qualified students. So here we go. Of the 1,886 qualified students, 1,008 were accepted. So we need to figure out 1,008 were accepted out of the 1,886, and we need to turn this to a percentage. And we're just dividing 1,008 by 1,886. And then we go right here. And that is our answer to that one. So now we need to find out the percent that were waitlisted. And we're just going to do the same mathematics. We have the 307 right here for the amount out of the total. So 307 students out of the 1,886 times that by 100 and then turn to a percentage, 16.3. And then one last number, I believe, right here, the amount that were turned away. So the amount that were turned away right here is the 571 divided by the 1,886. And then we times that by 100 and we get 30.3. Make sure to round to one decimal. Double check your roundings and don't put fractions if you don't need to. So now what's really great or really a bummer is it actually gives you the answers right here. If you get the quiz version of this, you're lucky because so not trying to tell people how to easily get a right answer to it. But if you get the quiz version of this, you are basically seeing the answers right there. So the answers to it are literally 53.4, 16.3, and 30.3. And that's it. That's a univariate categorical. And so good stuff right here. A lot of bar charts and pie charts. But Arden, I hope that helps out with that question. We can do at least one more here. Maybe I'll try to hop to a quiz question. But good stuff right here. Good practice. And lots of questions, so let's hop back into it. Okay. Arden, more questions. I hope that helps out with that one right there. Good practice. And let me know which questions you have. I'm going to pick a question if we don't have one by the end of this song, but feel free to ask anything, the quiz, the homework, whatever you're wondering about. I'm going to get quiz questions up, see if I see something. Is there only quiz questions I got this many? Oh, wow. There's not that many versions of quiz questions. This one's a bit bigger. That's a good one to do. Maybe we'll do Chapter 3 quiz. See if people put a question in the chat. 1, 15, 10, stat 201, Chapter 3 quiz. And you're welcome, Arden, anytime. Let's go check out the waitlist question on the quiz. Here we go. So with this right here, we have a contingency table, and important to know the differences. A contingency table is a bivariate display of categorical data. So Mosaic plots are the way to visualize them, and contingency tables are the way to show the numbers inside of them when we have two categorical variables. So let's go ahead and look at this data. First off, we can see the marginal displays of people who were accepted, waitlisted, and turned away. We can see right here the percent of each ethnicity, Black, Hispanic, Asian, and white, and the total amount of candidates right here. So this is a decent question for the test. It's very good on practicing if we can do marginals and conditionals. So really some great practice right here. When it says what percent of all applicants were Asian, it's actually talking about a marginal display because we're talking about all applicants. So of all the applicants would be here, and what percent are Asian would be right here if my eyes don't blur. So that's a marginal display. So we need to turn this to a percentage. What percent of all applicants were Asian is going to be 432 divided by 1314 and then times by 100 to get 32.9. Make sure to enter it in properly and do the following. What percent of students accepted were Asian? So of the accepted students, what percent were Asian? This is a conditional display. So when we do a conditional display right here, I'll take a screenshot of it. Conditional display means we're going to kind of look inside one variable. The percent, what percent of students accepted, so let's go to accepted only, were Asian, put a blue pen out, and the amount that were accepted, or what percent of students accepted were Asian. Be very careful, make sure you do it right conditionally because it's of the accepted students, another way to phrase it, what percent were Asian. So what percent of the students accepted? So we're looking within accepted students. So the answer is going to be 51 out of the 193. That is the percent of the Asian students from the accepted, or what percent of students accepted were Asian. So let's go right here, 51 divided by 193, times that by 100 and get 26.4. So great job, Laura, right there. 100 points, Laura. No, Laura, I'm going to throw out all the point buttons. Laura, I didn't know. I'm just trying to do a little extra help right here, and you're working along. That's perfect. What percent of Asians were accepted? So if you look, they're asking it a different way right here. So when you say what percent of Asians were accepted, now you want to say of the Asian students. So we'll highlight it. Of the Asian students, what percent were accepted? So that's a different way of saying this, of the Asian students. Like, yeah, Laura, anytime. And if you have a question, we might have time for one more. I try to throw in stuff in the videos to help out. See, that's different, 11.8. So that's of the Asian students, what percent were accepted. So just drop those questions in the chat and Brian will learn how to type eventually. Good stuff right there. What percent of all students were accepted? So the percent of all students that were accepted is going to be, if we go to another marginal display right here, I just love screenshotting it over. Why not? So what percent of all students were accepted? We need to go to right down here because this is another marginal. And the percent of all students that were accepted is the following. So that's of all the students, what percent were accepted. And so we have to go here to 193 divided by 1314 and then times that by 100. And we get 14.7. As long as we did not make a decimal error, we should be fine. Yes, we got it. Good work, good practice. This is a very good question at practicing your conditional and marginal displays. If you can answer these questions repeatedly and well, then you understand how to say, like, of this, the percent of all students who are accepted, the percent of Asian students. Be careful when it asks a conditional display. Just make sure you're understanding what a conditional versus a marginal is. We did the rain, no rain. There's the depressant. Do that one. We did this one. I think we only have, we did this one last time. So if you're looking for this one, check out last week we did it. Pretty good question right here. You know, we could end on this question. Probably the more complicated one than the antidepressant one. So let's do this one and we'll probably end on it and then I'll send the announcement for class. Let's go back here. Okay. So let's go right here. 120, 10, Stat 201, Chapter 3 quiz, political ideology. Great place to end, right? Here we go. Let's check it out. Okay, so this is a political ideology question and gender. So if you notice here, we asked two questions. What is your sex and what is your political ideology? So with this right here, we have the answers for sex and we have the answers for political ideology. Notice how it immediately addresses it by saying, what is the conditional distribution? That means looking within one variable, like of the people who are female. So to do this, we need to look at only the females. So we go here and take only this data right here. So this is how these numbers will be computed. We're looking at a condition given someone is female, what's the probability they're liberal? All the mathematics here follow the pattern of this number divided by this number, as in the percent of females that are liberal is 38 divided by 85. And that is a condition given. Given someone is female, what is the probability that they're liberal? And the answer is 44.7%. Next, we need to find out the probability given they're female. What's the probability they're moderate? That would be 37 of the females out of the 85, and that would be 43.5%. So the remaining should be like 11.4 or so. I'm guessing 11.4. 11.8. Close. Close guess. I think I've done them all correct. I'm a little worried I did it too quickly. We're going to do the same thing for the males right here. The males, we would just look at only the males. So the numbers are calculated by 54 divided by 118. That's the percent of males that are liberal. You can see right here the ideology is given. Liberal male, liberal, moderate, conservative. And then we'll do the same 42 divided by 118 to get these numbers right here. So we're looking at only the males to do a condition. Given someone is male, what's the probability they're liberal? Given someone is male, what's the probability they're moderate? Given someone is male, what's the probability they're conservative? And all numbers will be solved, once again, the same way. We take this number and put it over that number. So 54 divided by... I wish you could just put the mathematics in there and it would solve it for you. Maybe there is a way. I've never tried that. I don't think it would give you the right answer. It'd say like, nope, you didn't answer it. So 45.8 and then 42 divided by 118 times by 100, 35.6. And then 22 divided by 118 times 100, 18.6. And so here's the interesting thing. Males are more likely to be conservative. If you look at this right here, there's about a 5% increase. Females are more likely to be moderate. I thought this usually has bigger differences. Hope I did it correctly. Females are a little bit more likely to be moderate. Yeah, I think it turned out this way. Ooh, did I get like a different version? So females, there's the bump in male conservatism, and females a little bit more moderate. If you notice right here, the percentages on females are 43% moderate or 44, and that's female moderates compared to 35%. Get it both on the same screen at the same time. You can see the male moderate is that. Female moderate's higher at this. Male conservative is this, where female conservative is a little bit lower, and they're about equal in liberalism. So what we notice here is there's a slight association. So they do not appear to be independent. Independent means you would know nothing.
It doesn't matter.
It doesn't matter if someone's male or female, would tell you nothing about their political ideologies. But in truth, if someone is male, they're a little more likely to be conservative. Not a ton, just a little more likely according to this, wherever they're at. So they're a little more likely. So there is significant differences for at least one group, where females have a lower value of conservative, where males are about twice as much, going from 12 to 18%. So yeah, definitely a little bit of a difference. And wait, I didn't complete the whole thing. But really good work on these. These are good questions, good testing of conditional versus marginal displays, which is a lot of this chapter, but a lot of practice. With that, Puppet Shark, it's time. There we go. Puppet Shark's jumping in. Mewbot's reminding us all about that extra help. We'll be starting class here in 25 minutes. So join in anytime. I'll see people in class. Bye for now, everyone. Bye.